How's it going, guys? Thanks for tuning in. This is my week 3 video on reading strategies in math and science. So today I'm going to be talking to you about one of the tools that we read about for math from the article Using Graphic Organizers to Improve the Reading of Mathematics by Brazelton and Decker. So I'm going to focus on graphic organizers, which out of all the tools that we read about, that one just seemed like a really great tool for breaking down complicated problems and helping students to understand what is the problem actually asking, and then figuring out what are the little pieces that I can solve. It's really great for students who might look at a problem and say, well, I don't even know where to begin with this thing, so I give up. So let's go ahead and go through the different steps that the graphic organizer takes us on. I'm going to spin the camera real fast, so pardon that spin. All right. Zoom in for you guys real fast. Okay. So as you can see with this graphic organizer, it's a really clean sheet of paper that has just a bunch of answers, and starting from the top, students work their way down, breaking the problem apart, and by the time they reach the bottom, they will have an answer. So the first step is to restate the question. So a lot of times with complicated word problems, it's not really clear what it's asking, and gives you a bunch of data right at the beginning, and then doesn't ask the actual question of what it wants you to solve for until the very end, which can be kind of confusing for students. From there, we want to think about what are the parts of the problem that will help us solve the problem. So what are the different individual pieces? After that, we want to make a plan of action for how to solve this thing. So on these lines here, students can actually start looking at the problem and taking the pieces and just determining, well, where do I start and where do I go from there? After that, moving down to step number 4, we have these boxes here where the students are actually going to take what they wrote in step 3 and they're going to apply it to the problem. So they're actually going to do math in these boxes here to solve for the answer. After they actually get the answer, there's a really important step that says check to see if your answer is reasonable. Often in math, especially with story problems, students may get an answer that's way out there, or in the wrong units, or who knows. So having that one check there is a really good way of making sure that students are paying attention to what they're doing. After that, write your answer and you are done. So this next year, I'm going to be teaching pre-algebra, algebra 1, and algebra 2. So I figured that I would take a word problem from algebra 1 that I actually used last year. It actually doesn't look that the verbiage on it is not terribly crazy. It's pretty concise. But I still found that my students kind of struggled with it. And I think one of the primary reasons that they struggled was some of the wordage. There's some important math vocabulary in there that if you don't know what it is, you can't really get started. So the question states that the sum of 3 consecutive odd integers is 93. Find the integers. Right? So those math vocab words that I was talking about was consecutive, odd, and integers. So this would be a really good tool, I think, for students working alone and also in groups. So if somebody didn't know what one of those words meant, they could get together and discuss that before moving on. Once they figured out what the problem is actually asking them, one of the ways they could rewrite it that would simplify it just a little bit would be to write it as find 3 consecutive odd integers that add up to 93. So it's a little more clear before moving on. So the next step is to find the needed data. So I think this is probably the step that the students struggle with the most. It's really easy for them to figure out, well, I know what an odd integer, or I know what an odd number is, 1, 3, 5. Those are examples of odd integers. And those actually happen to be consecutive odd integers because they are the closest numbers to each other. But how do I take that and how do I solve given the stipulation that it says that they have to add up to 93? So in algebra, one of the things that we talk about is being able to assign variables to pretty much anything. So by working together, students should be able to figure out, well, if I make my lowest consecutive odd integer to be the value of x, I can go from there and assign values for the other integers as well. So, for example, we know if our first odd integer is 3, the next odd integer after that is going to be 5. So we know in order to get to 5 from 3, we add 2. And that's true of any consecutive odd integer. You add 2, you get to the next one. So we can make the statement that x plus 2 is equal to our second odd integer. Along those same lines, the integer following, if we add 4 to the original integer, we'll have our third odd integer. The last part that students will need to do before moving on to solve is figure out how do I put together an equation that is going to help me solve this. So if we go back up here and we notice in our, actually let's use the one that we rewrote, in our sentence here, it says we want these integers to add up to 93. Well, if we've just done these three things, why don't we just add them together and set it equal to 93? So that's exactly what we do here for our equation. We get x plus 2 plus x plus 4 equals 93. So those are our integers there, and we're ready to go. All we have to do now is move down and do our plan of action. So, looking at our equation, looks like we have a whole bunch of variables and constants on the left that could probably be simplified a little bit. So, students should see that they can combine those things together. So we're going to add our variables and constants up on the left side of the equation for our first step. From there, we want to start figuring out how to isolate for x. So that first step for isolating for x, we're going to have a constant, and that constant happens to be 6. We'll see that down below. So in order to get the variable isolated, we want to get 6 over to the right-hand side by subtracting it from both sides. Next, we want to get rid of that 3 that's multiplying that x, and the way that we cancel that 3 is by dividing both sides by 3. Then we're left with an x equals statement, and so from there we need to figure out what does x actually mean, and we'll get to that in a second. So jumping down to step number 1, all I did was we wrote down what our original equation was, and then like we said in step A, we're just going to combine our variables and our constants, right? So looking here, let's see what we have. 1, 2, 3 x's. So we have 3x, and then we have 2 plus 4, which is 6. And all of that equals 93. So we're done with step number 1. For step number 2, like we said, we wanted to subtract that 6, right? So we ended up having that plus 6 there. So in order to cancel it on the left, we need to subtract 6 from both sides. When we do that, we end up with 3x equals 87, which completes step 2. For step 3, we now have that 3x equals 87, so we have 3 times x. So students should see that they need to isolate that x, so they can do that by dividing by 3. So if you divide both sides by 3, you're going to end up with x equals 29. Well, what does that mean? What is x equals 29? One of the cool things about these graphic organizers is that students can always refer back up to things that they've already written. So if they do that, if they go right back up here to part A of step number 2, it says let x equal the first odd integer. Well, we saw down below that x equals 29, so that must mean that x is our first odd integer. From there, should have a pretty good idea of what those numbers are just logically, but why don't we use the statements that we actually made. So we have x plus 2, so if we plug in our 29 again, 29 plus 2 is going to be 31, and then then for the next one, 29 plus 4 is going to be 33. So it's a pretty good likelihood that those are going to be our answers. But let's double check it just to be sure. So 29, 31, 33, well, they're all odd, so that's a good sign. And if we take the string of numbers there, so we say 29, 30, 31, 32, 33, well, looks like those are all the consecutive odds. So I would say that fits those stipulations that we made earlier. There's one last check that we could do, though, and that would be to add those three numbers together and see if they total 93 like the problem was asking us. It turns out that they do, so we can go ahead and say, yes, the answer is definitely reasonable. Write our answer on the line below, and we are done. So as you can see, this is a really good tool for students really of any level in mathematics to be able to take problems that they're struggling with and breaking them down, whether they're struggling with complicated verbiage or vocabulary they're not familiar with, or even steps, and being able to go back and see the steps that they've done. All right, thanks for tuning in, guys. I'm looking forward to seeing you all next week. Take it easy.